Evaluate the integral by the method of residues. Integral 0 to pi log sin x dx. Solution: consider the integral over c log 1 minus e raised to power 2 iota z dz is equal to integral over c f of z dz, where c is a contour rho 1 to rho 2 gamma 2 pi iota n pi n gamma 1 rho 1. Within the contour f of z is irregular, so that by Cauchy's residue theorem we have integral over c f of z dz is equal to rho 1 to pi minus rho 2 rho 1 to pi minus rho 2 f of x dx plus integral over gamma 2 f of z dz plus integral over rho 2 to n f plus pi plus iota y into iota dy plus integral over pi to 0 f for x plus iota n dx plus n to rho 1 f of iota y iota dy plus integral over rho 1 gamma 1 f of z dz is equal to 0, or I1, I2, I3 plus I4 plus I5, I plus I6 is equal to 0, or iota 3 integral over rho 2 to n log bracket starts 1 minus e raised to power 2 iota bracket starts pi plus iota y bracket close plus iota dy is equal to integral over rho 2 to n log 1 minus e raised to power 2 y bracket close iota dy, because e raised to power 2 iota y is equal to 1. And iota 5 is equal to n2 integral over n2 p1 log bracket starts 1 minus e raised to power 2 iota into iota y bracket close into iota dy is equal to integral over n2 rho 1 log 1 minus e raised to power minus 2y bracket close into iota dy. Hence, as rho 1 tends to 0, rho and rho 2 tends to 0, n tends to infinity, we have iota 3 is equal to 0 to infinity log 1 minus e raised to power 2y bracket close iota dy, and I5 tends to integral over infinity to 0 log bracket starts 1 minus 2 e raised to power minus 2y bracket close into iota dy is equal to integral over 0 to infinity log 1 minus e raised to power 2y bracket close into iota dy. It follows that I3 plus I5 is equal tends to 0. Again, limit z tends to 0, z f of z is equal to limit z tends to 0, z log bracket starts 1 minus e raised to power 2 iota z bracket close is equal to limit z tends to 0 log bracket starts 1 minus e to e raised to power 2 iota z over 1 upon z form of infinity upon infinity, so is equal to limit z tends to 0 minus 2 iota e raised to power iota z over bracket starts 1 minus e raised to power iota z over bracket starts 1 minus 1 upon z square bracket close is equal to limit z tends to 0 to iota z square e iota z over 1 minus 2. This z square comes to numerator, so it is 2 iota z square e iota z over 1 minus e raised to power 2 iota z form of 0 upon 0. So limit z tends to 0 limit z tends to 0 4 iota z e raised to power iota z plus 2 iota z square into 2 iota z raised to power 2 iota z is equal to 0 upon 2 iota e raised to power iota z is equal to 0. Hence, by theorem, if limit z tends to 0, z minus a f of z a, and if c is the arc, theta 1 is less than equal to theta is less than equal to theta 2 of the circle, modulus of z minus a is equal to r, then limit r tends to 0 integral over c f of z dz is equal to iota a theta 2 minus theta 1. So we get iota 5 tends to 0 as rho 1 tends to 0. Similarly, iota 2 tends to 0 as iota 2 tends to 0. Rho 2 tends to 0. Now we shall evaluate iota 4. Now we have iota 4 is equal to integral over pi to 0 log bracket starts 1 minus e iota z e raised to power iota z into x plus iota n bracket close dx is equal to integral over pi to 0 log bracket starts 1 minus e raised to power iota x into e raised to power iota e raised to power minus 2 n bracket close tends to 0. As n tends to infinity, we have integral over 0 to pi f of x dx is 0, or integral over 0 to pi log 1 minus e raised to power iota x dx is equal to 0. Since 1 minus e raised to power 2 iota x is equal to e iota x, bracket starts e raised to power I minus iota x minus e raised to power iota x is equal to e raised to power iota x is equal to e raised to power iota x bracket starts 1 minus 2 iota sine x. Therefore, integral over 0 to pi log bracket starts 1 minus 2 iota e raised to iota x sin x bracket close dx is 0, or integral over 0 to pi log of 2x dx plus integral over 0 to pi log bracket starts 1 minus iota dx plus integral over 0 to pi iota dx plus integral over 0 to pi log sin x dx is 0, or log of 2 into pi plus minus iota pi over 2 into pi plus iota pi square upon 2 plus integral over 0 to pi log sin x dx is equal to 0, because log minus iota is equal to minus pi upon minus iota upon pi upon 2. So this term, these two terms will cancel out. So log sine of x integral over 0 to pi log sine x dx is equal to log of 2 pi. Hence integral over 0 to pi log sine x dx is equal to minus pi log of 2.